Today, Sarmazda Labs will be showing you how we complete PCR and gel imaging on DNA samples. Our first step is to thaw our previously frozen DNA samples. Then, we label one of our specialized PCR tubes for each DNA sample and add the respective DNA into the tube. Next, we create master mixes of the PCR reagents according to the number of samples. Each master mix contains sterile water, forward primer and reverse primer, which identify the region of DNA to be amplified, dNTPs, which are the building blocks of DNA, and Taq DNA polymerase, an enzyme that connects nucleotides together. We aliquot one reaction volume of master mix into each tube, mix them well by pipetting up and down, then place them in a thermal cycler. While the samples are in the thermal cycler, we create a 1% agarose gel. We mix 0.4 grams of agarose, a white powder, and 40 milliliters of 1x TAE buffer, which acts as a solvent. We heat the mixture to dissolve the agarose, and when the mixture has cooled, we add ethidium bromide to serve as a fluorescent dye. The mixture is then poured into a cast, where the bubbles are popped, and a comb is placed in to create wells in the gel. While the gel sets, loading dye is added to the DNA product in preparation for the gel. Again, we mix them well by pipetting up and down in the tube. The DNA and dye is pipetted into the wells in the gel. The gel is run on an electric current to pull DNA fragments down. The DNA moves from the negative to the positive node because DNA backbone is slightly negatively charged. Finally, the gel is photographed in the gel imager, then disposed of in the proper waste container due to the hazardous ethidium bromide.